Welcome students, you're welcome to another video lecture series of General Mathematics 2. It is 102. This is study section 5 and we shall be treating Introduction to Differentiation. At the end of this study section, you should be able to describe what the slope of a curve means, define what is meant by derivative of a function, and discuss the differentiation of a polynomial function. Now, the slope of a curve. Taking a look at this curve as you have been taught in MT1 lower coordinate system, do not forget it is the art of representation of points in a space using reference lines. This is y-axis and this is x-axis. Do not forget the y-axis is the one that continues in the upper direction and the lower direction, and which is the vertical, and the x-axis is the one that continues at the right and the left-hand side, which is the horizontal. Do not forget. So the act of representation of finding the coordinates of a point in space in reference to the x-axis and in reference to the y-axis. Do not forget. Now you can find 2 points on the space and then find the distance between them, and also find the slope between them, and the slope will be what? The change in y over the change in x, due to y over due to x. That is the slope. Now we shall be treating that of a curve. Now let's assume you now have a curve instead of a straight line. Then the curve looks like this. Now the curve looks like this. This is the x-axis and this is the y-axis. Now instead of having a straight line, you are having 2 points like this. One is like this, and one is like this, and one is like this, and one is like this. Many points, and you now have a curve passing through them. Now you have to find the gradient of or the slope. Don't forget the slope is also the same as the gradient, which is distance between 2 points in a plane. Now you have to find the gradient of this line. Now it's not possible for you to draw a straight line through them and then try to find the distance, but here all you have to do is find the gradient at each point, like this, like this, like this. So the first thing you do is, when you have to find maybe that of x1, whatever, you draw a tangent, a straight line that touches that point. When you draw that straight line, then you now find the highest here, the highest value here, then it is what you use to draw your slope. Now let's go back. You understand what I mean. This is the curve now in the straight line. This is point P. Now this is point P, and this is point Q. Now you have to find the gradient, the slope of this curve. Now do not forget, P must have x1, y1, and your Q must have x2, y2. Normally, if you have to find the gradient of a slope of a straight line, it should be delta y over delta x, which will be what? y2 minus y1 all over x2 minus x1. Now, taking a look at this now, all you have to do is draw a tangent, like I said the other time, through the curve. Then locate your x1 and x2. Now, here you agree with me that in a curve like this, your x increases by a function which is the x, and your y increases by a function which is the y. Now take a look at this. You must take this into consideration. Now it means your x2 becomes, now having this kind of thing on the curve like that, now P and Q, now your x increases by the x and your y increases by the y. This is x2 and this is y2. Now let us go back. Now your target is to locate the slope of the curve at a point P. To achieve this, you should keep P constant and move Q along the curve towards P. While doing this, the slope of the second line PQ will vary. As Q moves closer and closer to P along the curve, the slope of the second line varies until it approaches a constant limiting value. This limiting value is referred to as the slope of the curve at point P. Now you will see this now here. This is the curve. This is the curve, and now you have drawn a line through P and Q. Now, this line now, which is x2, which is x2, y2, q, x2, y2, it has to decrease. You have to bring it down to P. And as you are doing this, it will be coming down, until it reaches a limiting constant value, like we said, like we read just now, a limiting constant value. At this stage, your change in x will tend to 0. Now in this figure, you will notice as the second line PQ moves along the curve, now the increment ds at this stage tends to 0. Now at this stage, you will know that there is no more change in the what? In the x. Now let us go. We have to find the slope of the curve. That is example 1, y equal x2 at the point x1, y1. Now take a look at this. Now you have this, your y-axis, do not forget, and your x-axis. Now you have a curve like this, and you have to find the slope of the curve y equal x2 at the point x1. Now let's say this is P, x1, y1. Then this is Q, s2, y2. Now you have to find y equals x2 at the point x1. Now the first thing we should have to do is now here P is the first point here, and Q is the second point here. Now you will agree with me that your y will be s square, your y1 will be, that is x1 square, and your y2 will be what? S2 square. Yeah, that will be the first point and the second point. And now if you have something like this, your y1 will be equal to y plus delta y. That means you are going to have something like y equals y1 minus delta y. Now, and you will agree with me that your delta y will be equal to y2 minus y1. And then from here, you can have your y2 to be equal to delta y plus y1. Equally, you are going to have your delta x as x2 minus x1. And definitely you are going to have your x2 to be what? To be delta x plus x1. At this stage, let me clean this so that you can be able to now at this stage you are going to, if you have your y equal to x2, now at the second point, which is the point you want to bring down to P, you are going to have your delta y plus y1 equals your delta x plus x1 squared. That is y becomes delta y plus y1, as I said earlier, and your s becomes delta x plus s. Now expanding this, you are going to have now delta y plus y1 equals delta s plus x1 delta x plus x1. That is the expansion of these two. Now here you have delta y plus y1 equals delta s square. Do not forget delta s square. then plus x1 dx, then plus x1 dx plus x1 squared. Now, having this with you, what you do is take this y to the other side. Now delta y becomes delta x squared plus x1 dx. That is x1 dx plus x1 dx becomes 2x1 dx. You plus this together, plus x squared, x1 squared, then minus y. Do not forget, and what is y here? Your y, you know, becomes 1. That is minus x1 squared. Now this one we cancel this. Now it becomes y equals dx bracket square plus 2x1 dx. Now what you do at this stage is we are trying to find the derivative, which is dy dx. Now divide all sides by what? By dx. Now you have dx divided by dx, dx, dx. Now you have delta y all over dx now equals dx, which will cancel 1, plus 2x1. This one will cancel this one. Now, as I told you the other time, that as the point at the second point on the plane begins to draw down, it begins to limit itself until it tends, the x tends to 0. Now, if the x tends to 0, that's if the x tends to what? 0. At this point in time, you substitute it now, you add the y, the x, this one will be 0, then what you have left is what? 2x1, which is your final answer. Now, let us take a look at the derivative of a function. Here you will use the concept of the slope, that which we have done earlier, the slope of a curve at a given point, to define the derivative of function at a given point. Now take a look at this graph here. This is the y. This is the y-axis, and this is the s-axis, like you are seeing here. And this is the slope. This is the curve, I mean. And then now, like I said, you have drawn a line through it. Now, this point, this is the second point Q on the graph, and this is the first point P. Now, drawing lines with reference to x-axis and y-axis, you have your first point here to be equal to x, and the second point here to be x plus. Don't forget, this sign also means the x. This sign like triangle here means delta x. Now you are having here the change in y. The change in y will now be equal to the first point on the y-axis is a function of x, while the second point on the y-axis will be a function of x plus delta x. Now, if you are having the first function of x, you understand, to be this, then you are having the second function to be this. Now, your change in y, that is delta y, which is to be here, is also here. That means your delta y equals what? F of x plus the x minus f of x. I hope you understand this. You subtract the lower side from the higher point. Now, that is your delta. Now, to have your delta y dx over there, all you have to do is divide both sides by what? By the x. Now you have your dy dx equals f of function this minus f of x all over what? The x. That is how to do that. Now let us solve this example. Now find the the f prime x, that is the first derivative actually. Now don't forget, what I just did now is called getting the derivative of a function using the what? The first principle. Now that is what you will now apply here. If you have the first f prime of x to be, let's function of x is what? 3x plus 2, that is the first example. You have to find the what, the f prime x. Now, the first thing which you are going to do is, this is f of x. Now, the f x plus the x, that is the second point on the point, will now be what? Wherever you see x, don't forget you put this 3 into x plus the x, right? Plus 2. Now, you expand, this will give you 3x plus 3 dx plus what? Plus 2. Then you now go to the second step, which is subtracting to get your dy. Subtracting f x plus the x minus f of x. You now have 3x plus 3 dx plus 2 minus 3x minus 2. Don't forget minus, we change this sign here. Now, once you have this, 2 minus 2 cancels, 3x cancels this. Now your delta y will remain only what? 3 dx. Now 3 dx in this situation, divide both sides by what? By what? By dx. Now you have delta y all over dx. 3 dx divided by dx will give you now 3, which is your final answer. Now if you apply that same step in solving this second example, you are going to arrive at your answer, which should be 2x plus 3. If you get that right, that is the answer. The second example. Now let us go to differentiation of polynomial function. Do not forget, you have been taught under polynomials the general representation of a polynomial function, which is written here, f of x, a subset n power x plus a subset n minus 1, like that, till you get to a subset 0. Now, in this kind of situation, don't forget there are variables and there are powers in this kind of function. So we are going to be getting the differentiation of a polynomial function in 3 weeks. Let us do that of a differentiation of a constant function. Let's say y equal to k. Now we are going to differentiate a constant function y equal to k, differentiate a power function f of s equal to s raised to power n, and differentiate a variable function y equal to ku, where u is a function of x. Yeah. For the first function, a constant function, where your y equal to what? K. In this situation, you know that your f of x equal what? K. Now, for you to now find the f of x plus the x, you now have k again. Your f of x equals to the x equal to k. Now, to subtract f of x, don't forget, plus the x minus f of x, that would be what? K minus k, which is equal to 0. Now, don't forget this is equal to y. F x plus the x minus f of x. Now, let's see, the y equals to what? 0. In this situation, dividing both sides by the x equal to what? 0. That is the first one, the call of a constant function. Now, for the second one, where we have to define the derivative of a power function, let us consider f of x equal to what? X raised to power what? N. In this situation, you find your what? Your f of x plus the x again. Now, in this situation, your f of x will now become x plus theta x raised to power n. Now, using binomial expansion, let's say by binomial expansion, I'm sure you have been taught in the MTH 101 binomial expansion. You expand this. Now, you have your f of x plus the s equals s raised to power n plus n x raised to power n minus 1 dx, now plus n minus 1 x raised to power n minus 2, the continuation, the x square plus, till like that till you get to your what? The x square. Now, in this situation, you bring this down, you have a, forget, this is n. Now, in this situation, you have your, now don't let us expand, let us just subtract straight, subtracting f plus the n minus f of s. Now, you subtract this and this, all you have here is n plus n plus n minus 1 dx plus n minus 1 x raised to power minus 2 dx square, now plus dx minus x raised to power n. So here it means this will cancel this now, and it will remain like this. And it now will erase the first part. Up to this point, or up to this point. Now what we have left to now be delta y equals n, yes, raised to power 1 dx plus n minus 1 x raised to power n minus 2 dx square, now plus dx n. Now let us divide outside by the x, since that is what we are trying to find the derivative. Now if we divide all by dx, it means we have n x1, yes, dx will cancel that one, plus x1 is x n minus 2 dx, it will remain only 1 dx, plus this one dx all over and all over dx. Now if dx tends to 0 at this point in time, we have here the y dx equals n x raised to power n minus 1. The x, it tends to 0 here, multiplied by all this will be 0, and this one to 0. Now we have the general representation of the derivative of a polynomial, which is equal to the y dx equals nx n minus 1, and that is exactly how to differentiate. If you have linear functions, any function, for instance, you have to differentiate 5x. So what you have to differentiate x raised to power 5, or you have to do is n, you first bring it to the back 5, then x 5 minus 1, so you have 5x equals to 4. Now that is just a general way of deriving a linear function. Thanks for listening.